Morning. Today we are going to discuss variance of discrete random variables, and at the end of the lesson, learners will be able to calculate and interpret the variance of a discrete random and solve problems involving variance of probability distribution. So let's have a review. The previous lesson we learned that the mean of probability distribution gives the expected outcome of a repeated sample. So if an experiment of several times, the mean of all outcomes will close to the mean of the random variable. So in this lesson, we will learn how to quantify the spread of data in probability distribution and use the calculated variance to measure how much is probability of the spread around mean. So I have this following example. This one. In school, two games are conducted using six-sided dice. For game A, you will win 20 pesos if the results of rolling the die is 1 and it's 8 peso. If the result is 2, otherwise you lose 10. For game B, you will win 24 pesos if the result is 1 or 2. Otherwise, you lose 15 peso. The table shown below show the probability distribution for winning or losing the money for both games. The question is, what is the variance of each game? So these are the data. So there's a probability, and it's the probability, of course, that is the range, and it's the x values. Okay, so we will use these principles. How to calculate the variance? So the following formula must be used. Variance is equal to summation of the x squared multiplied by probability of x minus the square of the mean, where this is the variance, the random variable, p of x is probability of x, and mu is the mean of the random variable. So this is a Greek alphabet sigma. So the square of the sigma, that is symbolize variance. So we have already the formula, and other formula can be used also. The variance, the n inflation, the summation frequency of x squared minus the summation of all frequency squared and n minus 1, and also this one. Okay, sigma square variance, and if we square root this one, it will become standard deviation. Of course, x is score, and is the total frequency. So, as per the example in the previous slides, so we have the game A and game B. By this data, we can calculate the variance of each game. So, how can we calculate the variance of each game? Therefore, this is the solution. How to do it? Of course, we have to step 1, find the known facts of the problem. And step 2, solve for the mean. So, what are the facts in game A and game B? In game A, we have the x, 20, 8, and of course the negative. These are the base equivalent. And the probability correspond to 20 is 1, 6. 8, 1, 6 also. And of course, negative 10, 4, 6. This probability. For game B, if are the following x's, 24, and of course, negative 15 when you lose. So 24 corresponds to over 6, and 15 negative corresponds to 4 over 6. How can you solve for the mean? We can solve for the mean of game A simply x multiply the probability plus x multiply the probability minus 10 multiplied by 4 over 6. So we have a mean of negative 2. How about for game B? So we have mean 24 multiplied by 2 over 6 minus 15 multiplied by 4 over 6. So we have negative 2. So they have the same mean. So we have read the mean, so we can solve for the variance. So this is the data from the given game A and game B. How can we solve for the variance for game A? Simply using the formula. So we have already the mean. Substitute the mean here. And of course we have the x and the probability. So the variance 20 square multiplied by 1/6 plus 8 square multiplied by 1/6 minus 10 square multiplied by 4 over 6 minus and the square of negative 2. Therefore, using calculator, variance is 140. If we have already variance, we can calculate for the standard deviation. Just simply square root of 140 is 11.3. So we have already the variance and standard deviation of game A. How about game B? Same process, we have the mean of negative 2. Calculate the variance using this data and standard deviation. So we have the variance of 338, square root of 338 become the standard deviation. So how can we interpret the results? Of course, these parameters, we can interpret this one. So to interpret the results, calculate the standard deviation. The standard deviation of game A and game B are 11.83 and 18.38 rather, respectively. Since game A is smaller standard deviation, this means that there are more data that is closer to the mean. When game A is played many times, notice a smaller spread of variation of winning or losing than playing this. So that's the explanation. Next, can you try it? This one. And I will read this. The students in English class took a quiz with 5 questions. The random variable represents the number of questions answered correctly. The probability distribution is given by the table below. So we have the x, row score x, and probability of x. So our x are 0, 1, 2, 3, 4, 5, and corresponding probability are 0.08, 0.07, 0.16, 0.21, 0.25, and 0.20. The question is, what is the variance? Using the previous example, formulas, and how steps, we can calculate the variance of this problem. Okay, can calculate now. So finish calculate the variance. So this is the solution. Of course, we have the given. Step 1, find the known facts. Already have the facts. So x are 0, 1, 2, 3, 4, and 5. And how can we solve for the mean? Of course, using the mean formula. 0 multiplied by 0.08 plus 1 multiplied by 0.07 plus 2 multiplied by 0.16 plus 3 multiplied by 0.21 plus 4 multiplied by 0.25 and 5 multiplied by 0.26. So the mean is 3.17. So we have the mean, we can surely solve for the variance. So using the formula of variance, substitute the given values. So x0 multiplied by probability which correspond 0.08 force 1 square multiplied by the probability and 2 squared multiplied by 0.16 plus 3 squared multiplied by 0.21 plus 4 squared multiplied by 0.25 and plus 5 squared multiplied by 0.23 minus 3.17 squared. So what's the variance? 230. And if you want to calculate the standard deviation, just make a square root of this one. So square root of 230 is 15.7, so we have the standard deviation. So what's the interpretation? To calculate standard deviation, get the square root of 230. This means that most of the scores differ from mean within 15.17 above and below. So we already answered the question. So for what do you think? What does it mean when the variance of the discrete random variable is equal to 0? So it's up to you to research about this question. So for exercises, I will give you the following scenario. In a convenience store, the number of teller X busy with customer at 12 noon varies from day to day. Past records indicate that the probability distribution of X is as follows. So this is the X, this is the probability, and the questions are, 1, what is the probability that exactly 4 tellers are busy at 12 noon? What is the probability that at least 2 tellers are busy at 12 noon? At least. 3, what is the probability that fewer than 5 tellers are busy at 12 noon? And 4, what is the mean of the probability distribution? And last, what is the standard deviation of the probability distribution? So how can we answer this one? Using the previous examples. So we have the exercises. So what are the answer for these questions? So we have the solution. So we have already given for problem. How can we find the probability that exactly 4 teller are busy? So use x equals to 4. So probability at exactly 4 tellers. So probability is 0.212. So this is 4 exactly 4 tellers. So probability is 0.212. Number 2, find the at least 2 tellers are busy. So at least 2 tellers. So this is the list. So 2, and of course 3, 4, 5, and 6. So we have to consider this one, and the least is 2. So just add the probability. So that is the answer for number 2. So what's the solution? So of course all probability that equal to 2 and greater than 2. Okay, just add 0.078, 0.155 plus 0.212 plus 0.262 plus 0.215, so equal to 0.922. So this is the probability that at least 2 tellers are busy. For number 3, how can you find the probability that fewer than 5 tellers are busy? So fewer than 5. What are the numbers that fewer than 5? So it could be 4, 3, 2, 1, and 0. So just add the probabilities fewer than 5 tellers. So this is the solution. So probability R is 0.029 plus 0.049 plus 0.078 plus 0.155 plus 0.212. So this is the probability. 0.523. Okay. So next question. You can use also the table. So by using the table, we can make or solve the required data easily. So list the x, and of course list all the probability. Just multiply the probability and the x. So x multiplied probability, 0 multiplied by division becomes 0, 1 multiplied by this one, and this is the results. So on and so forth. So these are the product of this x and p of x. Then using the formula, so just add the product. So we have 4.11 summation of x multiplied by probability of x. So that is the mean. So the mean probability distribution is 4.118. This implies that in the long run, we expect that the average number of tellers who are busy at 12 noon will be 4.118 or 4 to the round off. 5. Standard deviation. Using this table also, just list the x, the tellers, the probability, just square the x values, and the x squared multiplied by the probability. So 1 squared multiplied by 0.049, so this is the results, and so on and so forth. So, and make summation of this column, so we have 19.438. So variance, use the formula. So we have already the value of this one is 19.43 minus we've already the mean and number 4 item 4118 square this one. Therefore we have the variance of 2.465 and the standard deviation as the square root of this 1 or the square root of x squared multiplied by p of x minus the mean. So substitute the given data. Therefore we have the standard deviation of 1.57. So we've answered all the required data from question 1 to 5. So the key point of our lessons, in a probability distribution, the variance of random bar is solved by subtracting the square of the mean from the sum of the product of the square of the random variable and the probabilities. For the variance, random variable x is denoted by, of course, sigma square and given by the formula sigma square to summation of x multiplied by p of x minus the mean square. So this is the variance formula. And another, small standard deviation indicate that more of the data is clustered about the mean, while a large one indicate that they are most spread out. And the variance is the square of the standard deviation. So these are the key points of our lesson.